Hi everyone, this is Sunny from Database Tech. So today I had come up with one more new session on SQL performance tuning and query optimization. But before we start, we need to understand why query optimization is required. So let's understand that with this figure. In this figure, you can see we have tree. And now if I will ask you we need to cut this tree, might be some people will use X, some use hammer or some can use knife. What I mean is different people can use different tools to cut this tree. Now what is important here? Time taken by the tool to cut this tree. Here in this example you can see X is taking 30 minutes, hammer which is taking 30 days and knife which might can take 3 months to cut this tree. So it's obvious that we will go with X. Why? Because it's taking lesser time to cut this tree which is 30 minutes. If we will use X, it can save our time, it can save our cost, it can save our labor. So we will go for X. Same thing happens in database also. Let's understand this with the example. Now we have the data, okay, which you can see below. So this is a table name as games. Now if we have to fetch the data where ID is equal to 13291, like any ID. Let's suppose we need where ID equal to 4. Okay, so we need data where ID equal to 4. So we need this output. Now we have different people in the team and I need this output and I am asking this to all the team members. Now different people can use different queries to get the output. So what matters here is time taken by the query to get the output. Some can use the query like this or some can use where id in 4. Although both the queries can get the same output, but what matters is time taken by the query to get the output. Only that will get approved. Because what we have to do, if you are working in the company, if you are working in the production server, you have to take care of the performance, which is very mandatory. Right now we are fetching a single row, but there can be the scenario where we have millions of data, millions of rows and millions of records you have to fetch. At that time what matters is performance. Okay, because the users cannot wait for the output, they need output in quicker time. So for that your query should be very fast. Okay, now to achieve this, what we have to do is we have to optimize our queries to improve the performance. And how we can do that? By using several steps, by using several ways. Okay, I will show you them all one by one. So let's understand them one by one practically in SQL Server. Okay, now coming to first one, we can use indexes. Use index for commonly used columns in the where clause. Now what does that mean? Let's understand this in SQL Server practically. Let's first remove this. Now here you can see the output from this query. If you have to check the execution plan, what happens internally in the database, for that what you have to do is you have to click on this icon. When you hover this icon, you will see it's saying include actual execution plan. So click on that. Now when you execute this query again, here earlier it was only two tabs, results and message. Now when you execute this, after the click on this execution plan, you will see one more tab getting added, which is execution plan. Click on that. Now hover here on the table scan. You will see from the first row it's showing physical operation, which is table scan. Now what does that mean, table scan? Although what we get here only single row, and if you will check how much data we had in this table, it's more than 65,000 rows, and from that table what we need is a single row. When we execute this query, what happens internally, there was a full table scan, which means all the data has to be read. Okay, internally what the processor, it checks all the rows, it has to check all the rows. You can see in the 1 2 3 4 5 6, in the sixth row you will see number of rows read, which is 65535, all the rows. So it has to read all the rows to get this output, which is not good because we need a single row, but internally it has to check all the rows because there was the full table scan. And with this query, what happens is there was estimated CPU cost, which you can see here, it's 0.072167, which is bigger. Okay, so we need to improve this, we need to reduce this estimated CPU cost and other things, and we don't need to read everything from the table because we need a single row from this table. So how we can improve the performance here? We can achieve this using indexes, as I said, and how we can implement that, let's see. Now if you want to see, when I go here, it's gone. So to get the output, what you can do the right click, show execution plan XML. Here you can check. Let me show you before and then I will show you after implementing the index. It was a table scan. Okay, here you can check all the data, estimated total, subtree cost, and estimated rows. Let's see, number of rows read, if you can find that. See, estimated rows read, which is 65535. Okay, now let's first implement index. And how to implement index? Create, let's implement clustered index on clustered index, and the name will be CLUST index on table name. What's table name? Games. And for which column? ID. Okay, create clustered index. So we are implementing here, either we can use clustered or non-clustered. And if you are not aware of clustered and non-clustered, you can go through my previous session on same, which will give you all the details and all the idea about the clustered and non-clustered index. So we are creating here clustered index, and the name of the clustered index is this, clustered index on. Okay, on is a keyword. Now the games is the table for which you are implementing the clustered index, and ID is the column. So let's execute this here. Command completed successfully. So we had implemented clustered index on this ID column. Now when we execute this again, you will see the difference. Okay, so click on the execution plan. Here, hover here, you will see the first row. Earlier it was full table scan, but now in the physical operation you can see it is clustered index seek, because we had implemented now clustered index on this table, and the number of rows read is 1. Okay, and also you can see the estimated CPU cost has also been decreased now. Okay, and if you need to check or if you need to compare, show execution plan in XML. Now earlier it was 65535. Now it is clustered index, estimated rows read, which is this one, estimated rows read. Now here earlier it was 65535. Now you can check the difference by own. Okay, and the difference in the CPU cost and other things. So by this way we can improve the performance using clustered index, or you can say using indexes. So we can use indexes for that columns which are going to use commonly, like for the ID column, or if you are using some name column in the where clause, commonly like you are using for, mostly if you had some column which you are going to use in the where clause again and again, so it's best practice to implement index for that column, which will increase our performance. Okay, so that's how we can use index. So that was it for today's session. So later steps I will show you, I will cover those in the upcoming sessions. For now, let's wrap up the session for today. We'll come up with the next session shortly. Till then, have a nice day. Bye bye. Take care. Be healthy and be safe and love your parents. Okay, we'll meet in the next session shortly with the upcoming steps.